I recently came across this blog on context engineering from Manus AI, and it's written by Yi Chao. And Yi Chao seems to be the co-founder and chief scientist of Manus. When I read this blog, I found it to be quite practical. So in this video, I'm going to walk you through the 6 tips that they have given in order to do good context engineering. So let's get started. So if you take an agent, the agent receives an input from the user via a prompt. And this agent usually has a set of tools to choose from in order to achieve the goal that it needs to respond to this user. And it executes a bunch of actions in the environment, which is the machine in which it is running. And the result of the action is fed back to the agent in the form of an observation. As the agent keeps interacting with the environment, doing different actions and observations, we build up the context. So the context typically looks like this. You have the instruction, and then you have the action and observation, and you have n number of this as the agent continues to do its action and observation loop. And engineering all of the information inside this is called context engineering, as we now are well aware of. Even though the agent does all this information, does all this processing and goes through the loop, the output that you get is going to be very small actually. So it's going to be very few words, or even it could be just simple structured output. The ratio between this prefill and the output that you get when you're dealing with agents is quite high. So that's what they're saying here. The prefilling and decoding is highly skewed, and the ratio is usually around 100:1. And one of the main driving factors is also the time to first token, or TTFT, the time between the user input and the time when we actually get the first token as output from the model. And they're saying that we can take advantage of key value cache in order to make it more efficient. So instead of just having the instruction in the cache, we can avail the cache as much as possible, and then put a lot of information in the key value cache so that whenever we want, we can quickly avail this information, and so the latency of the output is going to be significantly reduced. So as the system grows, the agent will have more and more tools at its disposal. Let's say to begin with, it has only like 10 tools, but as the system grows, you probably have 100 tools. Now what happens is it becomes a decision fatigue for the agent to choose which tool is appropriate to solve a given problem. And so they're saying that you need to avoid dynamically adding or removing tools mid-iteration. So if we look at this diagram, it'll probably be clear. So to start with, the context just has 2 tools, A and B. As the agent goes through different steps, we can notice that the tool C has been added. This is not a great practice actually. So what's a good practice is that of having all the tools that are available initially and then masking whatever is not needed. So here it is masked, but at step n+1, we can see that tool A is masked, but then tool B and C are available. So this is a good practice rather than adding tools as the context progresses. And they're saying that there are 3 modes of function calling. Auto, where the model may choose to call the function or not. So like the name says, it's completely automatic, and the model chooses whether it's going to actually use a tool or not. And then this required, where the model must call function. And then this specified, where the model must call a function from a specific subset. So you give a subset of functions and the model is going to use one of those functions. And this is the way we constrain the action selection by masking token logics directly. So that's how we mask specific tool calls, and we make it use only a subset of tools calls. And the next tip is that of using the file system itself as the context. So the modern day LLMs, they have a context window as high as 28,000 tokens. But because we are dealing with agents, even with this size of the context length, the observations can be huge. For example, when you're dealing with web pages or PDFs, these documents could be very long and the context window will still not be enough. And the next problem is that even though the context length is large, the model performance tends to degrade. And the third problem is that long inputs are expensive. You need to transmit and prefill every token, and this could turn out to be expensive pretty fast. So what they're saying is that we just treat the file system itself as the ultimate context. So if you look at this diagram, we can see that, without the file system, we have the action observation loop going on in the context. But with the file system added, suddenly for an observation, you pull the data from the file system and it comes into the observation, and then the agent does some action and probably stores some data into the file system. It could be some intermediate result or context or whatever. It could even be a document it created in the middle of the action that is getting used when it does action 4. So there is a loop going on before that data is actually used, and there's a free flow between the file system on the context. So as per their experience designing Manus, they're saying that this is a better system compared to a system without the file system. So the next point is that of manipulating attention to recitation. Recitation in large language models is a phenomenon where the model repeats or reproduces text from its training data or the prompt verbatim, rather than generating an original or contextually adapted response. So in order to do recitation, they are introducing a file in the middle where things get stored. For example, when handling complex tasks, it creates a to-do list, and then the to-do list is updated step by step as the task progresses, checking off the completed items. It's more like how we humans behave when we actually have a lot of things to do. We maintain a to-do list and we actually check off things in the to-do list. Similarly, they are going through an approach that's very similar to that. So without the recitation, we can see that the objective is initially set, and all throughout the different steps, it just goes through action observation cycle. But after the introduction of recitation, we can see that after a couple of action observation cycle, we have the objective being recited in the middle, and then the different actions continue. Probably after a couple of actions, the objective is again recited in the middle, depending on how many actions and observations are taking place. And talking of the number of observations and actions, they're saying that typically there are around 50 tool calls on average that Manus requires when it actually wants to accomplish a given task. So the to-do list is constantly rewritten as the agent is reciting its objective into the end of the context. This is all to avoid the lost in the middle problem. So if you recollect the curve of lost in the middle problem, we will notice that if the context is really long, the LLM tends to remember whatever is there at the front and whatever is at the end, forgetting everything that's in the middle. So to bypass this problem, they have introduced this manipulate attention through recitation. The next tip is very good actually. So it's to keep the wrong stuff in. So we as humans tend to hide our mistakes, or even with the model, we tend to do the same. By simply changing the temperature, what we do is we feel safer and more controlled, but it comes at a cost, which is that erasing failure removes evidence. So what they're suggesting is whenever the model makes any mistake, instead of throwing away that attempt and moving on to the next attempt and then seeing how it behaves, which is going to repeat the same mistake, we need to actually keep the observation that this one failed, so that the agent has a past record of what failed, and then in the next observation it's going to get it right. So it's not about hiding the mistakes, it's about keeping the mistakes. So the next tip is that of don't get few shotted away. Now, few shot prompting is when we give a number of examples to a given scenario, but when you're dealing with a problem like, say, reviewing a batch of resumes, the agent often falls into a rhythm. For example, we take the scenario where the agent is looking into different HTML files and converting them into Markdown. We can see that it's opening that, content saved to, open, content saved to, and this action is simply repeating. If the agent is set in this kind of a rhythm, then it's going to follow the rhythm all throughout. So in order to break that, what they're doing is they're deliberately tweaking it a bit so that, after a few actions, the observation is no longer just, content saved to, but it's like this is already the Kate time visiting a page on, and then you're going to ask it to actually save it. The motivation here is to increase the diversity, and they do so by introducing different serialization templates, alternate phrasing, minor noise, and formatting. So they change the formatting, and this controlled randomness is what breaks the pattern and tweaks the model's attention. So those were the 6 tips that we got from Manus AI. Hope it's useful for you to kind of implement in your agentic workflow and to improve it. So if you like the video, do like and subscribe, and I will see you in my next video. Take care.